Okay, this video basically takes you through how to represent a negative number using 2's complement method. It doesn't go into much detail, but it will show you how to convert negative numbers into negative binary numbers using 2's complement. So the main difference between this binary line here to the one that we normally use is the most significant bit, which is the one that's on the left, actually represents a minus number. So you've always got to remember that. Now if I was working with a 4-bit word, so if imagine all of this didn't exist, yeah, this would be my most significant bit and therefore it'd be a -8. But right now we'll work with the full 8 bits, and all we need to make sure is that we understand that this does not represent positive 128 anymore. This actually represents a negative 128. That's the most important bit. So I'm just going to circle that and just to make sure we know that. So imagine you get a question where they ask you that you need to represent a negative 100. So the first step I always do is write down the number I need to make. The main thing I need to do right now is figure out what I need to add to minus 128 to get to minus 100. Now that's straightforward, and that's why I picked the number minus 100, because it's dead easy. To get from minus 128 to minus 100, all I need to do is add 28. Okay, so the way that we do that is, right, it's going to be a negative number, so I'm going to pop a 1 in here, and then I need to make the 28 using the other 7 bits to the right. So a 16, an 8 and a 4 make 28. So if I add that 28 to the minus 128, I'm actually left with minus 100. Let me just show you how that works. So I've got the minus 128 there, so I'm just going to write that down there. And I've got the 16 and the 8 and the 4. So all these are added together. And what I'm left with is minus 100. Let's just take a look at another example, so we're clear, we know what we're doing. And again, I'll make it a fairly easy example so the maths is really simple. Imagine I want to make minus 30. Okay, the step that I always do first is write down the one that I need to make. So I'm going to pop here minus 30, and the question I'm asking is, what can I add to minus 128 to get to minus 30? So what I can actually do is just do 128, take away 30, which leaves me with the number 98. Yes? Yeah? Okay, so we're left with 98. So if I make 98 now, so I've got 64 plus 32 equals 96. 2 more, 98. Everything else is on the 0. So this number that I've made is 98. Now if I add that to negative 128, I'm actually left with minus 30. Okay, so that's a real quick way to do 2's complement. Just a few other things that will make you aware of is that, look, if we really think about it, the largest number we can make on this 8-bit word length is a 1, 1, 1, 1, 1, 1, 1. And this is 127. If this was 0, because that means that just add all these numbers together, we've got 127. Okay? Now, what's really important is, if this is switched on, what we're saying is, to this 127, we need to add a 1, which leaves us with a minus 1. Okay, and if I wanted to make a minus 128, all I need to do is take all of these ones out and pop in zeros all the way across. So we're using the full range of bits to create a range from 127 positive all the way down to minus 128. Now if we include the 0 somewhere in the middle there, we've got 256 numbers that can still be made using 2's complement from minus 128 all the way to 127. Okay, I hope you found that useful for your exam. Cheers.